Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. I'm Razi and I'm here to teach you mathematics. Students, we are doing chapter number 5 and it is about partial fractions. Let's start. Students, in our previous lecture, we have learned about the denominator that contains repeated linear factors and how we can make such type of fractions, partial fractions of such type of rational fraction. So we are continuing that process of making partial fractions, and the same rules are applied over here. So let's start. Students, question number 9 from exercise 5.2. The numerator is x minus 1 and the denominator is x minus 2 and x plus 1 whole cube. X plus 1 is the factor that is repeating 3 times, mean it has power 3, so it will have the 3 partial fractions. So x minus 2 is a linear factor and a single factor, so it has only one rational fraction. So we make the partial fractions a over x minus 2 plus b over x plus 1, c over x plus 1 whole square plus d over x plus 1 whole cube. When we multiply the both sides by x minus 2 into x plus 1 whole cube, which is the denominator of rational fraction, given rational fraction, we will get x minus 1 from left hand side and a into x plus 1 whole cube plus b into x minus 2 and into x plus 1 whole square plus c into x minus 2 into x plus 1 and d into x minus 2. Because the x minus 2 is in denominator in first partial fraction, so it will eliminate x minus 2 and the remaining factor x plus 1 whole cube. Similarly, these we get from B, C and D. Moving on, students, x minus 1 is equal to a into x plus 1 whole cube plus b into x minus 2 into x plus 1 whole square plus c into x minus 2 into x plus 1 plus d into x minus 2 is the equality between two polynomials. But we have, students, we have 3 linear factors in this. Students, we have 2 linear factors as x minus 2 and x plus 1. So we can obtain 2 values by putting a factor is equal to 0 from it, but 2 remaining values will be calculated or accumulated from comparing the coefficient method. So we start by putting x minus 2 is equal to 0, which means x is equal to 2 in above equation. When you put x minus 2 in above equation, which again is equal to minus x is equal to 2, the first factor add 2 minus 1 and the right hand side will become a into 2 plus 1 whole cube, and all the 3 terms b, c and d, all the 3 terms containing x minus 2 will be 0. So in this way we will get 1 is equal to a into 27, 2 plus 1 3, and 3 raised to power 3 is equal to 27. So a is equal to 1 over 27. If we in this way we get the first value, a is equal to 1 over 27. But when we put x plus 1 is equal to 0, the value of x will be x is equal to 1 minus 1. In above equation we will get minus 1 minus 1. We put the value of x is equal to minus 1 is equal to a into 0, as x plus 1 in first term there is x plus 1, so it will be 0. Similarly in second term there is also x plus 1, so it will also be 0, and c which also contain x plus 1, so it will also become 0, and d into minus 1 minus 2, the term containing d has no x plus 1 factor, that's why it will not be equal to 0, or it will not be eliminate from this equation. So moving on, minus 2 is equal to minus 3d, minus 1 negative sign will cancel out from both sides, and d is equal to 2 over 3. So we deduce, or we calculated another value, that is d is equal to 2 over 3. So by putting the values, putting the factors, linear factor is equal to 0, we got two values, a is equal to 1 over 27 and d is equal to 2 over 3. But we only have two linear factors, so we deduce two values, and we can only deduce two values. But if we have to calculate, or we have to find four unknowns, so two unknowns are remaining, that will be calculated or computed by equating the coefficients. So the second equation, that is x minus 1 is equal to a into x plus 1 whole cube plus b into x minus 2 into x plus 1 whole square plus c into x minus 2 into x plus 1 plus d into x minus 2. This equation can be written as x minus 1 is equal to a into x cube plus 3x square plus 3x plus 1. What I did, I solved the formula x plus 1 whole cube, which is equal to a cube plus 3ab into a plus b plus b cube. The same formula I have opened over here. The next term is b into x cube minus 3x minus 2. How I obtained this value? You can calculate this value by opening the formula x plus 1 whole square and then multiplying the value by x minus 2. So you will deduce x cube minus 3x minus 2. Plus c is moreover c into x minus 2 into x plus 1. These two factors will be multiplied, and we get c into x square minus x minus 2. The last factor is in a linear form, so we will not open this last factor. No, we compare the coefficients of x cube and x square. Why we are comparing only two squares? I mean, why we are comparing only the coefficients of x cube and x square? because we need only two values. We already have uh, obtained two values, so we only need two. That's why we are only comparing x cube and the coefficients of x cube and x square. If we have to calculate more than two or three or four values, then we will compare the coefficients of all coefficients. I mean the coefficients of x cube, the coefficient of x squared, the coefficient of x, and the constants that contain the uh, 0 of x. I mean x raised to power 0 is a constant number. So on right hand side, x cube has a coefficient a in first term, and x cube has a coefficient b in second term, and there is no x cube in third and fourth term. So we will take a plus b is equal to 0. Why is equal to 0? Because there is no x cube on left hand side. So where there is no x cube, the value of coefficient will be equal to 0. So b is equal to, we move a to the other side, so b is equal to minus a, but we already have calculated the value of a, that is 1 over 27. So over here, so the value of b is minus 1 over 27. Now we are going to compare the coefficients of x square. 3a, from where it comes from the first term, that is 3x square, and multiplying with a number unknown a. So the coefficient of x square is 3a, and in a second term the coefficient of x square is missing, so we left it, and in this third term there is the c, the coefficient of x square. So we have only two coefficients of x square on the right hand side, that are 3a plus c is equal to 0, because there is no coefficient of x square on left hand side. When we put the value of a, that is 1 over 27, at the place of a, we will get 1 over 9 plus c is equal to 0. If we take 1 over 9 on and the other side, we will get c is equal to minus 1 over 9. So in this way, students, we have got all the unknown values. A is equal to 1 over 27, d is equal to 2 over 3, b is equal to minus 1 over 27, and c is equal to minus 1 over 9. So we are going to put all these values in equation 1. Hence number 1 become x minus 1 over x minus 2 into x plus 1 whole cube is equal to a. The value of a is 1 over 27. So 1 over 27 into x minus 2 minus 1 over 27 into x plus 1, because the value of b is minus 1 over 27. And the value of c is minus 1 over 9. That's why I put minus 1 over 9 into x plus 1 whole square. Last but not the least, the value of d is 2 over 3. So we put 2 in numerator and 3 in denominator with along with x plus 1 whole cube, and that is the answer of the given question. Students, that's all from my side. Take care, and you will have to solve question number 11 of 5.2 as a homework to understand the concept thoroughly and